We have a very exciting collaboration between Nokia and Intel to address a most critical concern for our customer. How do you grow the network while keeping it sustainable so you can make a lot more money?
Today, along with Nokia, we're showing our Intel Infrastructure Power Manager. We've chosen two very important workloads in the telco network. First is a user plane, which is a DPDK-based workload. We're also showing a control plane signaling workload, in this case, specifically the AMF. What this product is about is saving power in the data center in the telco network, okay? So in a typical data center, telco data center, we have very varying levels of traffic throughout the day, right? So early in the day, we may have low traffic levels. As the day goes on, everyone's home from lunch, everyone's home from work, traffic levels go up, and of course at night, everyone's sleeping. So we have this cyclical pattern of data throughout the day. So why do we need to run the servers at max power all the time, right? We don't. We have this opportunity when the throughput's low to be able to vary the frequencies of the CPUs, reduce the power of the server, right? Save over a 24-hour period. So what this demo is showing is simply a traffic profile. This is from a standard COSP, right? As you can see, there's kind of valleys, peaks, right? It ebbs and flows throughout the day. And the power savings associated with that. So without Infrastructure Power Manager running, the server power is going to be more or less on max all the time, right? So it's a waste of power when we don't need it. With IPM running, we have a curve that's much lower, so the CPU frequencies go down, the power reduces, the fan speeds go down, so the overall server power reduces in the data center. This is one server. Imagine multiplying this against thousands of servers in a data center. In this specific case, without IPM, without Infrastructure Power Manager, no packet loss. When we enable power management and run the software, we also have no packet loss. So we can do power management very safely without any impact to performance. What Nokia is showing is that in a typical deployment, this is a real world deployment that they would show for their customers, we're saving an average of 40% on this server throughout a 24-hour period.
Here we have the data plane, simulation of the data plane. And as Steve already pointed out, here we have a typical traffic profile. And as you can see, without IPM running, the typical baseline power is about 340 watts. With IPM, we've reduced that substantially. So over a 24-hour period, what we see is a 40% saving in power.
40% is a number, if you think of it in terms of what it means for our customers, it's tens of millions of dollars saved in electricity bills. But to think that this is going to continue and get higher and higher, it just gives you an idea of what it would mean for their whole business. Don't have to worry about energy consumption, just focus on what you need to do, which is grow the network sustainably.